Hello there, it's Geoff here. I want to look at a couple of features in 3D Studio Max actually, and I'm really showing you the end result of what I want to achieve here. This is an image in Photoshop that's a render. Now the purpose of the feature I want to show in 3D Studio Max is one that they call normals mapping, or baking to a texture. So this wall here, stone wall, as you can see the light on here as it's displayed down this wall emphasizes quite a bumpy pattern there. Now I've been asked to do this a couple of times with the AEC guys, certainly for the idea that the Revit model, coming from Revit into Studio Max to make actually a more reliefed wall in here, and also the idea of putting in some IES photometric lights and you know, using them in my scene. So these lights actually come from Revit. These are the Revit IES lights that I put in my Revit file, and then they brought through into Max. So I haven't actually adjusted too much here in Max to give us the idea of using this Max. I've just created in Max the map, the bump map, or rather the normals map that I'm going to use for this demo here on the Max 2022 features. So let me jump over into Revit to show you what I started with. Here's the scene in Revit that I started with to go over to 3D Studio Max. I created this scene as part of our class work, but the idea is that I wanted to use these downlighters here. These are just some families I got in Revit, and this is a wall, and this is a texture that's included in Revit. So all of this is all pretty well standard Revit geometry. The only thing that I've changed actually is that if I select a light, one of the lighting units here, and look over onto the edit the type here, I've actually imported a particular web file, photometric web file. This one is 2.ies. I'll show you that, the reason for that now. The file I used is actually one of them that I've got myself, and in my library of IES files, this is a very common file that a lot of visualizers use for the IES. I think they're called NICE, N-I-C-E. They're a NICE collection, and these are the distribution of the photometric web that I'm using. I'm just brought this one in, number 2 here, because it gives us an idea of the distribution of light that I would use in such a downlighter on the wall. So that file is brought into that Revit file here. If I actually looked at the family that this is created from, clicked on view the family here, this is the luminaire that I brought in here. So this one is the luminaire here. So if I looked at the light source definition, it is showing that it's going to need to be a photometric web distribution, and therefore when I bring it into my geometry in here, I can see that it is actually a photometric file in here. So that's pretty straightforward. That's all I've done in here, is just bring in a particular photometric web file that I want to use in here. So from a point of view of Revit, there's not much I've done in here other than just change that file to be a photometric web file. I bring that into 3D Studio Max. But what I've done here, I did a relatively quick render here of this scene in Revit. So if I come back, that's my final work in Max. But if I come over to my Revit render, very basic render here, I've just clicked on draft render. This is just the draft render of that scene in Revit, just literally a few moments. The only reason I wanted to render it in Revit particularly, like I said, it's not a high-end render. The purpose of this was to look at this distribution here, just to see that I would actually get some distribution here. So in my Revit file, that's all I used. So what I'll do is send this all over to 3D Studio Max, and let's have a look at it in Max. Here I have the file in 3D Studio Max now. There's only a few changes I've made in preparation for this, in that I've actually put a texture on the floor here, and I've actually taken away that stone texture because I'm going to put another one in there. The import I used, I just do the normal import, filed, import my geometry here into Max. One of the things that I've spoken about before for people when they're importing from Revit is there's one thing we need to consider, just on a little side note here, is that if I come into my scene converter here, so I bring the geometry in scene converter, one of the areas that I like to work with in my Max model now that's come from Revit is to actually change the some of the features that are coming over, some of the components that are coming over. For example, when I'm working in 3D Studio Max, very often I'm thinking that the geometry that I'm creating, or the scene that I'm creating, will be used for a render. So for rendering stills, this, for presentation stills, but also it may be that the geometry and the entire file at some point may be taken over and used into some real-time rendering. So for example, if you're going to start thinking about VR, AR, and you want to use your geometry that's from Revit into 3D Studio Max and optimize those features of real-time rendering, we need to think about a workflow here that allows that to happen. And one of those workflows is that we need to convert some of those materials. So if I just looked on this editor here, I've got the scene converter showing up here. The current preset is the one, the ART render. This is the Autodesk Ray Trace preset. I can use this one, but you can obviously create your own presets. But the reason why I just wanted to use this as a preset, if I clicked on my materials here, you can see lots of materials that are available to us. And so these are my over here I have some conversion rules that are particular to this current preset. So the main one is the materials here. The materials that when we create our geometry in Revit, we'll be using an Autodesk material. So that's what the Autodesk library is that uses in Revit, the Autodesk material. I need to change that to a physical material. I want to change it to a physical material so that I can use physically based rendering materials in my scene here. So all of the materials I'm going to change over to physical materials. The maps, I'm going to change also those Autodesk bitmaps to just a straightforward bitmap texture. The Autodesk bitmaps would be associated with the Autodesk material. So in Revit, you will see that you have your Autodesk bitmap, and you have an Autodesk material. Similarly, we'd actually have some different not lights. I'll leave the lights. The lights are fine because the 3D Studio Max understands the photometric IES data. So I don't have to convert that. The other one is my camera here. The camera in Revit is relatively simple camera. As you probably know, if you use Revit, you can set the height of the camera, but there's not much else you can change. You can't change focal lengths very well and things like that. But here in Max, I want to be able to change those cameras from a free camera to a physical camera, target cameras to physical camera. So the camera that is in Revit will come in as a free camera, but I want to convert it into a physical camera. So those are the idea. Those are all I wanted to do in my import of my Revit file. So those pretty straightforward. I've just brought those in here. Now, if I look at the materials, then the materials that have come over, if I click on my materials editor here, let's say I jump over to this one on the floor texture here. This that one, delete that one, but this floor texture, this is the physical floor texture that's come over. It was a material in Revit which had two components to it. The material was called hardcore, site hardcore, and concrete sand screed. So these were the materials, these were the names that were given to them in Revit, but I brought them over and they've converted now these two into physical materials. So they're not the materials as they were in Revit. So the materials have changed, and also, as I said, the bitmap is changed as well. So it's moved over from a from an Autodesk bitmap over just to being a standard map. And I'm popping those into there. So that's pretty straightforward. It's the color, the bitmaps coming in here. Now the texture on here in the Revit file was using sand and screed or something like that, but I've just swapped that out and I put in my bitmap here that is representing my parquet floor concept here. So here's the parquet floor here, just a small panel. So that's all I've really changed in here. And the only other thing that I've changed, of course, is that this wall is changed as well. So what I want to do now is look at how we can change that geometry to create a normals map, so that I can see in my render quite a nice relief of the map, very bumpy. And also, if we then using that geometry later on, we can push that into a game engine or some form of real-time render. So what I'll do then is let's have a look at the process for that. Let's get started then. This stone area here is a what I'm calling low poly. So if I right click on here, look at its object properties, this is just a low poly stone wall it's going to be. So I click OK there. So it's a low poly. Now what I want to use, I want to create a high poly version of this wall that gives me the relief pattern. So we can create that in many ways in Max, but mostly what we would probably do is duplicate this geometry here and then actually physically use some form of displacement modifier perhaps, or some way of making the mesh more dense. So if I just come over to here, you can see on my browser here I've got the low poly version here, and if I just clicked on this one here, I can see that I've highlighted a high poly version here, build. Now if I come over to my properties of that over here, my modifier stack, I've got the original editable poly there. I've actually put an unwrap UVW on there to show the modifier, to show the unwrap, the UV within this, and you'll see the reasoning for that in a second. And then I used actually displace modifier, so I displaced this mesh, and then I put a turbo smooth on it just to clean it up. So if I looked at this, if I just turned off the low poly for the moment, you could see that there's a high poly wall there. So what I'll do with that is just come back, show my high poly here. Now the other version is my high poly wall I've got here. If I selected this one and turned off the build, this particular one now is exactly the same as before. It's just that I've collapsed it all down into just some geometry now. So with those two selected there, what I'm going to do is just right click on here and then hide everything that's unselected, and then perhaps come back to my perspective view, so you can see that I'm working on this geometry now that is showing my high poly version of the wall and a low poly version of the wall. If I click on, if I just hide my high poly version at the moment, just hide the high poly, that's a low poly, pretty straightforward. As I mentioned, there's my high poly version there. If I hide the low poly, you can see that that's the, if I hide the low poly, you can see that's just the high poly. But if I look at the object properties of this, you can see that there's faces here. I've got 66,000 faces here, and even if I come over to here to view these edge faces, we would see that it's relatively dense polygon count here. Now that particular model itself would take a little bit of time to render, so what we need to do is project a normals map that represents this relief onto a lower quality or a lower poly count here. Let me just turn off the edge faces there, and also I'll just come back to my low poly version here. So here's my low poly version of this. The process that I want to do is project a map onto here from a higher poly model. Now to do that, what we have here now within our render setup here, we've got a couple of concepts that have been, the render to texture. It's been around a little while. So if I clicked on render to texture here, this is the feature called render to texture. If anybody's been using this, then you would recognize render to texture. The only problem I found with render to texture is that it was a little bit clunky to actually get a workflow within it, to be perfectly honest. So even then, even before, when I was working with gaming industries and looking at UV texturing, it was quite a process to deal with this interface, and also sometimes it actually was a little bit problematic as well. So what's legacy now is we'll leave that as the legacy now. If I come back rendering, what we have now is this concept called bake to texture. It was available to us in 2021 and a point release and an update in 2021. It's very good, and I was using it when it first came out, and then just to see how it worked, and things were okay. The reason why I wanted to make it solid and show you was to wait until we actually had 2022 out, so that I can look at the actual process better here. So I'll just close that for a second, because I need to have both these two available. So I've got my low poly model that I'm working on, that's one there, and let me just delete that little projection there. So I've got my low poly version there and my high poly version there. So the high poly, low poly. The lower poly has got a UVW map on it, so that's showing you there the UVW map. And what I want to project the high poly version onto my bump map or normals map. So what we will do here is, within my low poly, I make sure I'm working on my low poly. I'll come into my render bake to texture. So here we are, I'm on my bake to texture again. Now this process is actually quite a lot more intuitive in its workflow than the original render to texture, I think anyway. And we have a lot of elements so that we can render to or bake to in the texture. So for example, the color, we can do that, or we've got other baked elements here. So if you're working with a different renderer, for example Arnold, you can render out some of the elements as well here. And if you render into a PBR, which is a physically based render material, we can render things like the roughness here, metalness as well. But what I want to do is render here a normal map. I'm just going to come into a normal map. A normal map is a higher definition of a bump map, and we'll show you the way that works. So I'll just click on normals here, add this map in, and then straight away I've just got this map coming in, so I can render this map. So here we have it here, just an entry here. And what's interesting about the entry now is that I can basically move along here to decide how it's going to be created and what parameters it's using. So on my low poly model, I'm creating a normal map, and then here it says projected from. So I actually have an option where I can project it from something else. So I want to project it from that high model. So I can pick from the list, and because I've only got these two objects in my, visible, I need it to be visible so that I can select it. I'm just going to say I'm going to pick my my high poly wall here, and I've got a few parameters here that I could change. Now we've got the concept of a cage here, which is quite good actually, and I would beg you to have a little bit of an experiment here, depending on the type of geometry you're using and what the relief map is and so on, and see how it works. The cage basically is this blue line that's around here, so it's a cage that's expands away from the low poly and away from the high poly, so that encompasses all the bumpiness. So in other words, it now on my low poly it puts this projection modifier on here, so that I could actually adjust the cage values down here and make it bigger to adjust the cage. Now that does work a lot, but also what I'm finding recently, particularly when I'm pushing this geometry over into a real time render situation, I'll use the ray trace from vertex normals. So basically I'm looking at the normal map based upon the tangents of the vertex against the model. Don't want to get that too deep into that, but it's a little bit more accurate than the cage. If I had a very light change in definition of geometry, I'll probably use the cage. But if I wanted to actually use something that really is definition like that, like this stone wall, I will use this. This one, the maximum ray distance, this will need to encompass my wall. So I'm going to say that is say 30 mil there, so that the depth of the bump going from the base of the bump to the top of the bump wouldn't really exceed 30 mil. So that's that's my that's the way I will deal with it there. So I'm going to try that. I find that quite useful now, particularly as we work with this. The UV channel, I'm leaving that at 1. If we were doing some light mapping, I'd need to do perhaps light channel 2. The image size is the square image here. I'm going to make that 2048, leave it locked at square, and over here it's going to be the name of the file is a low poly normal. It's a PNG. I'm going to put it out as a PNG. I could output to the file only, or indeed I could save it as a material. So if I wanted to save it straight into a new material, I'll just click on create material there, and then create a physical material like that. So I've then added that as a physical material. So now before we do that, we need to make sure that because we're creating a new physical material, I need to tell it where to go, and I need it to go into the bump. So it's going to go into the bump there. So it creates a new physical material and it pops that into the bump. Just a couple of things to look at down here which I'm finding actually quite interesting, especially as we move towards using our geometry from Revit into Max in preparation for, like I say, real-time render engines like the VR situation and the AR and presentations like this, is that we do have the opportunity of making a few settings here that are quite useful. So as I'm making a normal map here, I've got the norm options for the normals here. The normal map space is tangential, which is absolutely fine. There's a couple of options here that are relative to your view when you're actually displaying it on the screen, but we won't move to that at the moment. But the sync with here, I can sync it with anything else. So for example, if I know that I want to move it over into Unity here, or I want to use it in Unreal, then I would then synchronize my normals mapping situation so that it would be useful in Unity or Unreal. I've just been experimenting with putting it into Unity, certainly in the use of Unity Reflect. So I find that quite useful. So here I've got a disk output path that is put here, and I can create a render frame window for this at the moment. I'll click on bake here and then I'll let it run and then come back again, because this may take 10 or 15 minutes, and also depending on the fact that if I had a lot more maps to do, for example, any more elements, I could pop them in there. That's going to take a little time to render. So I'll just click on bake here, and there we go. So that actually would be the end. So if I just I would overwrite that file there, for example, it would start to render. Okay, that's finished rendering now, and so let's have a look at what we get out of that. So basically that's rendered at just my normals map at the moment. So I'll close that, and let's jump over to my materials editor. Here we can see this structure here. I could actually have my original mirror material and baked material showing up here. So these are the idea where we have a physical material here. I could pop that into there. So I've got my new baked material and my physical material. In this case it wouldn't really matter because I'm just using a normals map to display here, so I could pop that straight onto here like this. So I could actually then show right click on here, show material in viewport, show material, my baked material, sorry. So that would be coming back onto my material here in my viewport. So that would show my material in the viewport, so that I could actually view that in a render dialog. So if I just jump onto this material here now, we've got that material on there, but if I right click on here and just open a preview window, we could probably see the relationship between the bump or this normals map in here. So there I've got my preview here. If I look at the normals structure here, if I just unplug for the moment that normal in there, and you'd see the relationship here that is just the texture there is just showing as a flat texture. If I put in my bump into there, we would see that I've got some a bumpiness here in my texture. So I'll just close that. So this is working just as a normals situation. So when in my texture here, I've got my normals map here. If I view that map, like I said, this is the texture here. So this is being projected from my high poly onto my low poly. So I don't actually render, of course, the high poly. You'll notice here I've got another node placed in here, and really what this is available for is that this is a normals map and it's being put into this node here, and this node, if I double click on here, this allows me to have the normal map in here, which is the low poly one I've just done, and I can actually put an additional map in here as well. So for example, if I wanted to just put an additional sort of like gritty sort of map on top, so that just show you the bumpiness of the grittiness of the stonework, so I could have an additional level in here, and then it would drive that into the bump map there. So I think that's, you know, that looks extremely well like that. Now the other option is that now if I unhide everything here, unhide everything in here, and then go back to my camera reception cam in here, we've got our finished geometry in here. So what I'll do now, I've done the render. As you can see, the final render comes up in that I have this wall here like this. So this wall is now looking quite nice, I think, here in the final render. The final render actually in this particular one is not too outrageous. I haven't spent a lot of time on the render because I didn't want to complicate too many settings. In that, what I have is that I'm using that normals map here, and as you can see, because I use this distribution of light here, you can see the way it travels across and gives us some shady areas in the bottom edges of the stonework there, which is actually quite nice. So I start to get a much better feel of depth in my render. This was rendered with Arnold, so I haven't used any other third-party renders, just a simple Arnold render. If I go back to my 3D in Max here, the only addition I've changed here from the lighting point of view, or the render, I've added in these three portal lights in here to sort of deflect the environmental light coming into the scene. And the environmental light is, if I looked at my environment here, I've just put a physical sky map in there. I could use an HDRI. I'll show you in a moment about that. So essentially that's the feature that I really one of the features I quite like, and that is the normals map. So what I'll do now, I'll just show you I'll just start up another file and I'll show you how that physically based material is actually looking good even in a real-time situation. So I'll close this file and open up another file and show you that in real time. Now I've just saved out that wall just on its own actually, so that I can show you how it displays that bump in the viewport. So in other words, it's a little bit like how the game engine will work. So this is quite good. Now what I've done in my background, if I come to my environment here, in my environment I've just popped an HDRI image in here so that I've got something to reflect from. So I'm actually using an HDRI. You can see that's this one, sky, field and stuff like this. So this is the map I'm using in here. Now in 3D Studio Max, if I change my view to the high quality here, I can have this high quality here, and also make sure that my lighting and shadows are illuminated from scene lights. So because I've moved over to a high quality here, I'm actually using the GPU on my processor to display this. Now what I've done here is in order to sort of look at this stone wall and see that in real time movement, I've actually changed the wall here so that it's the texture of the wall. If I come over to my materials here, this particular wall material, this one here, I've actually added in some what they call roughness and metallic metalness here. Obviously you wouldn't have those metalness in a wall, but what I wanted to do is just to show you the effect that that new normals map is having on this geometry in real time. So in other words, if you look at this, as I turn and tumble this around, we can actually see some highlights here, like the reflections of the light. And if I move that around, you can see that it actually, in real time, it's changing. And of course, in real time, I'm seeing the distribution of the light in real time. Also, even because I've actually created the materials, physical materials from Revit, and I've actually used this HDRI in the background. On here you see, because I've used the physical materials, that Revit component comes in because I told it to convert to physical material. I'm actually using you can see that in that metallic look, I got the reflection of the sky and everything in here. So in real time, that is actually quite nice. I like that in two things are happening with the use of that normals map, is that I've got a real time bump showing on here, and then I've also got it in the render as well. If I with this item selected, which is my low poly, just to confirm, if I right click on here, object properties, this is still only got 6 faces on it. So the idea that this has only got 6 faces on it, but in real time I can move this around and you can see that the highlight moves across the bump. It's really good. So therefore, because it's a very low poly model, we can use that in our VR to look through our architectural walkthrough extremely well. Okay, so that is the real time, and then that is the simple render. So obviously I haven't got a shiny wall here to show you the highlights, but this is the render in Arnold. Like I said, the render in Arnold, I haven't done anything additional to this apart from I've imported it from Revit, made it into physical materials. I've done this this normals map on here, and I've just added in a couple of more lights in here to represent skylight portals to add some more illumination in the scene. Excellent. Next thing I want to show is that on another feature in Max 2022 is the slice modifier. Let's have a look at that. Okay, looking at the slice modifier now, I'm using the same model as I had before, but I'm just highlighted just one wall here. And the slice modifier, if anybody's familiar with the original slice modifier, it's a modifier that we got all the way down here, slice, and there it is, slice. So a slice would actually place a slice plane in the geometry here, and I've got the idea of refining the mesh. So that what that's done there is basically cut the mesh in half, and this one would be to split the mesh. So I've now got 2, but if I clicked on, remove the positive side, that removes the bit on the Z side or the negative side there. The slice modifier itself, if I zoom in here, you notice of course that the slice modifier is just slicing the geometry. It's not actually capping the geometry there. And I've found that when I've used the slice modifier in the early days, I had to use a slice and then put a cap modifier on it. And very often if I wanted to animate that slice moving through the geometry, sometimes it would be a little bit unpredictable as to how it would describe this geometry. And so I'm very pleased to see that the cap modifier is actually put inside here now, and the cap geometry is operated on in a certain way. So for example, if my model is a poly model, it would go for a poly or a mesh, or I can tell it to do a poly or a mesh, or leave it as automatic. I've been experimenting with this, and it actually works extremely well, in that, especially with the animation. So this particular piece of geometry, I've got now a cap on here, which is I've introduced here, clicked on the cap there. Now I can set a cap material. So this material here, what's going to be on this material is something that we can change here. It mentions here that set cap material, and it highlights then 1, material ID 1. So if I move over to my materials editor here and look at the material that my wall is, here's my original wall material in my slate material editor. Essentially what this material is that's the plaster wall there, and that's the default there, and then that's that brickwork out here. So essentially this material structure is being used for both the interior and the exterior. The only difference is that it's plugging in here, it's plugging in the exterior is going into here. So this material is our exterior walls. If I double click on here, we will see that this is the structure that's come over from Revit. This is the naming structure. It's called white wall there, brick common, and default wall. So those 3 materials there. Now they come over from Revit. They've been assigned IDs. It's what they call ID numbers, 1, 2, and 3 IDs there. So I've just introduced the fact that I want another material on the cap there. So on this material, if I set that number and said I'm going to have that as now I'm going to put that as 4, click OK, that allows me then to have another material in there as an ID. And like I mentioned, I do use physical materials a lot more now, because as I generally work with Max, I want to be able to make sure the geometry is available to pass through into other processes like the game engine and stuff like that. So I'm staying with the physical material here. So the physical material is here. I can call it, give it a name, and call it wall cap, for example. And here, if I look at the material colors, I can say, well, obviously I can change the colors here. Click on this one and make it completely white or something like that. It would work like that, or indeed just to be something different. If I change that material to something like pink or something like that, we would actually see it. Now at the moment we're not seeing it. I'm not seeing any cap change here. This new material is put into here, into ID 4. So I need to tell it that my material that I'm using for my cap is actually ID 4. So there's that magenta color there, if I wanted to use that. I could also use a map in there, so I'll just bring that down to white again there. I could also use a map in there, for example. And if I was just to zoom up here again, here there's several ways of using maps. So for example, I might actually create a map, a couple of types of maps here. If I come over here all the way down to my maps, and I looked at my tile map here, so all of these general maps, so we'll just move that over there. So this is my general, this is my maps here. So I bring all the way down to my general maps here, and this one is one of my procedural maps, one called tiles. I pop that there like that. I could have a tiled map put in there and pop that straight into my base color, so that you can see that the map is there. If I double click on that map now, you can see it's just a tile in. If I look at my advanced controls here, they've got the tile texture is this grey. I'll make that absolutely white, for example. And then my grout setup, I would have that, maybe make that completely black like this. And then I could adjust the tile in and shape of this. So for example, if I did the tile in, change the UV mapping, instead of, I could actually put another UV map on here, but for this purposes, very often it's just easier just to make it plainer from the objects X, Y, Z. It doesn't visually change anything there, but that's where my mapping would be. If I put some tiling on here, I don't know, 10 by 10 tiling on there, and then perhaps just rotate the Z axis to 45. You know, I've got a hatch pattern there on there. Maybe I'll make that even more, 20 by 20. So I've got a hatch pattern on the cap, which is quite nice. I could also say, well, I won't have that hatch pattern. I will actually create, I could put a texture on there. So I'm just going to come back off here, leave that off there, so that's not on. And then if I come back to my Photoshop over here, I could look at creating my own hatch pattern or an image that I could use. So if I come over to my little hatch PNG here, I've just created a very square map here. This is just 512 pixels square, and I just put 2 black lines on it like that. Very simple map, and I'm going to use that map on my cap in here. So if I come back to max now, if I then use that map, I could pop that on me. That would be just a bitmap that's coming in. I pop that there, and then I use that hatch that I've just created. I click on open there, and then I can put that straight into that base color again. So this is the same concept here, that I could adjust the way that mapping is going. So I'll say that once again, I'll do the same type of thing to have the map in there. If I changed its tiling once again, I don't know, 20 there, and then rotate this around 45 like this. So I've got a hatch pattern there, a little bit like the panel, pattern on the plan. So maybe I'll make that 45. So I've got a hatch looking like that on there, which I think pretty good, especially if I was to animate this. So if I wanted to animate this build going up from a drawing, for example, I could actually look at this slice modifier. If I come into the slice plane object within there, I could actually set this up and do a animation of this. So for example, if I make sure my let me just take this out of there. If I just made sure I'm at the start of my animation, bring my slice plane down, you can see that the slice plane now is actually working quite nice, in that it slices the plane and slices the texture as well, which is quite nice. So if I bring that right down to nothing there, and then place a keyframe in here, let's say I auto key there, and then place a key in there right at the start. If I come all the way up to say 100 here, drag this up, and so that I've got my entire wall here. So click on the key there, boom, like that. So I've got an animation of my slice plane moving all the way up, and that would work in a nice animation. So if I wanted to have an animation of the building growing up from my Revit file, I could. So what I've done here, if I just added this in the scene here, you could see that I've got my plan that's come out of Revit, and therefore I've got my building that I could actually bring up from the drawing, which is quite nice. So all that is being done with that slice plane, and then I put a texture on there. So there's a couple of nice features of 2022, and a little bit of a workflow into Revit through to Max and so on. And so there's a lot of features coming on, but those two particularly I quite like, especially for our AEC, where we're actually dealing with geometry coming from Revit. What can we do to enhance it in Max? Coming back to my last one here, just very briefly, that was my Revit, very quick render out of Revit. I used the wall now to make a nice render in here, and you know that was what I used. And I used this plan that I created. I just created this, brought this into the plan, the PDF that I put out of Revit. I just brought it into Photoshop here and created it as a PNG, and then put it onto a plane surface in my Max here. So that plane surface there was created just as a simple plane surface. Put that map on there. So thank you very much indeed. Thank you.